Okay, so several people, once again, just like metric to English conversions, people were asking me, hey, Mr. Lee, could you please do astronomical units? And that's going to be important if you are in my astronomy class or even in my physics in the universe class, because sooner or later we're going to be talking about very, very large distances. And it's going to be hard to get those distances to kind of make sense with our brains, to be quite frank. So what we do, instead of saying something is 1.6 trillion miles, that's a one with a zero, 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 all those little zeros behind it, that gets to be hard to kind of comprehend in our minds. So the concept of miles and kilometers are lost in space. So what we start doing is we start measuring things for the things that we know. For example, we look at our sun and we think of the sun. That's the thing that we know. And we say, okay, our sun has this mass. And then we look at another star that's like our sun, but a lot bigger, and we might say, well, that sun is 26 times the mass of the Earth. So we would call our sun one solar mass, even though that's not what its real mass is. We just say that it's one solar mass, so we can compare it to the one that's 26 solar masses. Well, that means it's 26 times larger than our sun. Or maybe there's another star that is not as big as our sun. So we might say it's a 0.75 solar mass, which means it's 3/4 the size of our sun. So the one that we use in astronomy within our solar system is what's called an astronomical unit. An astronomical unit, if you look at my little picture in the frame there, is the distance from the Earth to the sun. So from this little blue dot to the big yellow dot. Okay? But when we start getting out to things like Saturn or Uranus or Neptune, those are much greater distances. So what we do is we say, well, the distance from the Earth to the sun, right here to right here, is one astronomical unit, or 1 AU. Then we say, instead of saying, well, Neptune is 2.8 billion miles away from the sun, we compared how far it is away from the sun. So let's define astronomical unit. An astronomical unit, 1 AU, is the average distance from the Earth to the sun. Now that distance actually is, on average, 93 million miles, or 150 million kilometers. It's easier to write these in scientific notation. That's where we say, well, how many zeros we have here? 1, 2, 3, 4, 5, 6. I'm going to actually go to 7 here. I'm going to say 9 point, oops, that's not 9.3. 9.3 times 10 to the 7th power. Really what that says is that it's 9.3 times 10 7 times, just like we did in the metric system. So I just moved the decimal point over 7 times. 1, 2, 3, 4, 5, 6, and 7. Add some zeros in there. And you see that this number and this number are pretty much the same number. We would write 150. We would move the decimal point between the 1 and the 5. So we're going a little bit further. We would say that would be 1.5. This is miles. 1.5 times 10 to the 8th power, because we moved the decimal point 8 spots. And that would be how many kilometers it is. All right? So basically what I'm saying here is that 1 AU equals 9.3 times 10 to the 7th power. All right? Miles. Now, if we look at a planet like Neptune, Neptune is equal to 2.8 times 10 to the 9th power miles. Wow, that's a big number. That's really saying, if you look at 2.8 and 9.3 and you think 9.3 is larger, you need to look at this number over here. That 10 to the 9th means it's 2.8, and we move that decimal point over 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a whole bunch of zeros. This is a much larger number than 10 to the 7. Okay, so that's actually 2.8 times 10 to the ninth. That's another way of saying billion miles. Okay, Earth is 9.3 million. Neptune is 2.8 billion. That's a lot further. Okay, so how do I figure out how many AUs it is? Well, this is what we did in metric to English conversions in the last video that I made for you. And that's where you take what we know. So we know that Neptune is 2.8 times 10 to the ninth power miles. And the metric conversion that we're going to multiply it by, well, 1 AU, this is right here, 1 AU is 9.3 times 10 to the 7th. So we're going to put this as a fraction. Make sure miles is down below. AU, astronomical units, is up on top because I want my answer to be in AU. All right? So 1 AU is equal to 9.3 times 10 to the 7th power. Okay, this is where I would use my calculator. Okay, but every calculator is a little bit different, and I don't want you guys to learn on my calculator. I would much rather you guys learn on using Windows. So I'm going to bring up my Windows calculator. If you do a search and minimize this screen, there we go. If you do a search, come on, Mr. Lee, you can do this. If you do a Windows search with the little search bar down here in the bottom and type in calculator, this app should come up. And just make sure up here in these three little bars, it might say standard right here. Make sure it says scientific. So you click those three little bars and click scientific. Okay, so at this point, if you can, I don't know if you guys can see this very well or not at the top. Let me size that a little bit. What we're trying to do is we're trying to multiply that number right there, which is 2.8. And this is how I would write it. 2.8. And I want to do the exponent. Don't hit times 10 to this. It's not going to work. You're going to have to hit EXP. That's your scientific notation I was talking about. So hit that EXP. That little E plus means times 10 to the, and that was the ninth power. So that's 2.8. Really what I'm saying is 2.8 billion. And the next thing you want to hit do next, you don't want to hit divide yet. You want to hit equal. And look at that. It did it for you automatically. It turned out from scientific notation to a regular whole number, 2,800,000,000. Okay? Now I'm going to multiply that by 1. That's going to be 2.8 billion. And I'm going to divide it by 9.3 million. That's the distance from the Earth to the Sun. So I'm going to hit divide, which is 9.3. And I'm going to hit exponent 7. So that now means 9.3. Move the decimal point to the right 7. So that would be 93 million. Okay? 9.3 times 10 to the 7 is 93 million miles. All right, now I hit equal, and now I'm going to get this really big number. What's important to note with that really big number, unfortunately, is a little off the screen there. You can't quite see it. Right there, you see it's 30 point, and then a whole bunch of numbers that follow it. That's the 30. That's what we're looking for. That is your astronomical units. So, go back to this sheet right here. My answer is 30 AU. Okay? What that means is Neptune is 30 times further from the Sun than Earth. It really helps us to kind of understand how far away Neptune is when it's 30 times further away from the Earth. In this case, in my model, and I'm going to Bring this, make this picture large again, so you guys can see. And this model right here, if this is the sun and this is Earth, this is about 5 centimeters. So is this model correct? Well, no, Neptune would have to be 30 times further. 30 times 5 is 150 centimeters. That would be 1.5 meters. Neptune really should be out here. But this would not be a very good model to hold if the planets were all spread out appropriately. And that is astronomical units.